Hi, welcome to day one of Accelerated Math for 8th grade. Today we're going to look at ratios and proportions. Now this should be somewhat of a review, but it's definitely a great place to start as we get into this year and all of the awesome math concepts and strategies that we're going to be doing. So the first thing you're going to notice is I have in front of me what you would normally see if we were all together, and that would be your paper with your notes, with you to be able to fill in some learning as we go through today's lesson. What I'm going to ask is that you go ahead and make sure you have your spiral, you have paper, you're organized, you're sitting at a place that's going to allow for you to just take time to focus in on this lesson and begin taking notes on your own. And if you need to, if you find that I'm going too fast, you can pause, rewind. Make sure that you're trying to get as much information that you can written down on your end. So we're going to go ahead and get started by looking at this word, ratio. So when you have probably heard of the word ratio before, would be dealing with a lesson on fractions, because we know that a ratio is one type of fraction. And so as we think about a ratio, we think about, in this situation here, you want to be able to write a ratio in 3 different ways. So here I'm looking at the ratio of A to B. So how can we write that in 3 different ways? Well, we know that we're going to write A to B as a fraction, A to B using a colon, and I can write A and the word to B. So these are our 3 different forms that we're going to see throughout the math year when it comes to that ratio and how we can begin to write those ratios. Moving on, we're going to look at proportions. Now, ratios and proportions, of course, are so related because when you take 2 ratios and they are set equal to each other, we create proportions. So A to B, we know is a ratio, and I could tell you that A to B is equal to C to D. Here I have a proportion. I have 2 fractions that are equal to each other. And I want to also be able to think about this proportion. How can I write it differently? So there's actually many ways. I can take A to B and I can say, well, what if I said B is to A? And using what I know about this first proportion, if B is to A, then D is to C. And you can look across and you can talk about that relationship between the 2 different ratios. I can also look at that proportion and make a connection with my numerators and how they relate to the denominators. And I could say, well, in that case, then B must be related to D. And if B is to D, then A is to C. Now at this point we have 3 different proportions. We could then do one more. And you're right, we could do, oh yeah, D is to B, because I'm looking at just taking those 2 and finding that inverse, so C is to A. Keep these 4 different forms of proportions somewhere in your notes because it will be important that you're able to think flexibly about these values and how they all relate to each other. So the next thing you're going to see here in our notes is this idea that when we are solving for proportions, sometimes we might see something where we have x is to 3 as, oh, I don't know, 6 is to 9. In this case, as we read through this, to solve a proportion with the variable in the numerator, okay, so there's our x, variable in the numerator, multiply each side by the denominator. What does that mean? Well, the idea here is how do you isolate x? So what do I know about x? I know that when I have x over 3, I do have that 1 coefficient there. And if I wanted to isolate x to find out what is that value, I can multiply both sides by the denominator. The reason I'm choosing the 3 is because x needs to be isolated, and right now it's being divided by 3. So the inverse operation would be to multiply both sides by 3. When I do that, 3 times 1/3 is 1x, or 1. And on the other side, I would end up with 18/9, which can reduce to x is equal to 2. And if I come back up here, I can see that 2/3 is equal to 6/9. I'm going to go ahead and erase that for the sake of going on to our next section. All right, how do we write ratios? The way you write a ratio is very much dependent on how the words are written and what these sentences are telling us. So we have a volleyball team plays 14 home matches and 10 away matches. Now you're going to notice we have 14 home and 10 away. So number 1, find the ratio of home to away. And so you're going to see I could use variables to write this ratio, or I could also then begin to fill in 14 to 10. Or I could write my fraction, 14 is to 10. Now in this case, I know I could simplify 14/10 to 7/5. But because we're talking about a very specific situation with games, we can also leave it as 14/10 in this situation. Number 2 says, find the ratio of home matches to all of the matches. I'm going to put T for total, just so that I'm not confused with the variable A. So I know my home is 14, and together when I look at 14 and my 10, I know that there was a total of 24 games played that whole season. Number 3, find the ratio of away matches to home matches. So again, very similar to number 1, we're simply just looking at the way that the words are described, and I'm following along with my 10 to 14 because I have 10 away to 14 home. Find the ratio of away matches to the total number of matches. And again, I can do my 10 away matches to 24 total. Okay, so as you're writing your ratio, order and structure become very, very important. Okay, let's move on. Solving proportions. So here we see we have 4 proportions that we need to find the value of each variable. Thinking back up here to those proportions, we're looking at this idea that we want to isolate the variable, and I also know that there is the value 1 in front of any one of these variables. Now, I can go ahead and I can think about multiplying both sides by 30. Again, because I know it's 1x over 30 times 30 over 1 leaves me with x, because I can cross simplify and I get 1x. And I can come to this side and I have 30 over 1 times 11 over 6. I can cross simplify and get 55. Now we could also talk about the idea that if I have 11 over 6 is equal to x over 30, I can look at the relationship across, and I know that 6 times 5 was 30, so 11 times 5 is 55. So that's a great thing with proportions. You use your knowledge and your number sense, and you're able to look at many different ways to solve these problems. Number 6, I have 1W is to 35 as 4 is to 7. Again, I can go ahead and I can multiply both sides by 35 over 1 in order to isolate that value, leaving me with a W. Now, as I'm looking at this, I'm going to, of course, decide to simplify my 7 and my 35. I'm going to factor out 7. There's 1 7 in 7, 5 7s in 35, and 4 times 5 is 20 over 1, or W is 20. Again, you might also look at this and you can realize 35 divided by 5 is 7, and the inverse of division is our multiplying by 5, so 4 times 5 is 20. Number 7, in order to isolate for M, I'm going to multiply both sides by 12 over 1. 12s can be factored out. M is now equal to. Now as I look on this side, again, I can simplify multiplying fractions, and I can factor out my 2's, and I end up with 54 equals M. Now, of course, I'm going to want to check this. So here we had 9 halves is equal to 54 over 12. Does that make sense to you? Well, sure. 2 times 6 is 12. 9 times 6 is 54. The last problem, isolate for Z, multiplying both sides by 54. I know that I can factor out 54. I'm left with 1Z or Z. And I have 5 9ths times 54. I can factor a 9. And 6 times 5 is 30 over 1. So Z equals 30. Of course, you're always checking to make sure, does that make sense? 30 is to 54 as 5 is to 9. 54 divided by 6 is 9. 30 divided by 6 is 5. So I know that my answer is correct. So we've gone